All right, here's the last video. We are now going to measure the amount of radioactive isotope in the rock. And remember, we're going to do both uranium and carbon-14. Let's go ahead and start with uranium. And before we do, I want to remind you that we'll be answering these questions. How was the rock formed? So we'll take a close look at that. What happens to the amount of uranium-238 isotope in the rock over time? And then we'll then move on to carbon-14. We'll measure carbon-14, and we'll use what we observe when we measure the amount of carbon-14 in the rock to answer the question, can we use carbon-14 to measure the age of the rock? So we're measuring the amount using that Geiger counter, but could we use carbon-14 as an isotope to determine the age of the rock based on what the Geiger counter tells us? And then we have this last question here, which is reading the data table to figure out the age of this rock. All right. So we're going to get started. It's uranium-238 is selected. That's the isotope we're monitoring. Remember, you can monitor it using the white box above probe type, or you can use the chart. Now, the first thing I'm going to do is I'm going to erupt the volcano. Now, remember when we were using the tree, we had to plant the tree because that's how trees are born, when you plant the seed and the seed germinates. Well, with a rock, we're going to erupt the volcano. So this will help you with that first question. How was the rock formed? All right, let's go ahead and erupt the volcano. Oh, something's happening. Here we go. Rocks flying out all over the place. Boom. Okay. So take a look. The rock is really hot right now. Look at the percent of uranium-238. The rock is cooling. Okay. Took 0.25 years for it to cool down. All right. And we're going to monitor the amount. So look at the amount that we have. Oh, now all of a sudden, look how long, look at the amount of time that has taken for it to start to change there. Okay. So this is the amount of uranium. You can look at the graph here. All right, so what is happening to the amount of uranium-238 over time? All right, so just like what we did with the carbon-14 in the tree, I'm going to pause this video and allow the simulation to continue on the background because it takes a while for it to get down to 0%, and we'll check in back at that time as you get closer to 0%. Okay, so we are back. You can see right now we're at 0.1%. And look at these numbers here, a lot of numbers. So let's figure out what this value means. Remember, when you have 3 zeros and then a number in front of that, we would be in the 1,000th place, right? The number to the left of the comma would be at the 1,000th place. If you have 6 zeros and a number after that, then that number will be in the millions place. So we're well over 1 million. And then if you have 9 digits, okay, so they could be zeros or other numbers as well, as we have here. If you have 9 digits, then the number to the left of that comma would be in the billions place. So far we're at, there has been 43, close to 44 billion years that it has taken for the amount of uranium-238 in this rock to decrease to just 0.1%. We're not even at 0% yet. Now, think about the age of the Earth. How old is the Earth? The Earth is 4.6 billion years old. So we don't have any rocks on this Earth right now that started off with 100% uranium that are anywhere close to 0%. Because the Earth is 10 times younger than the amount that we have here. It takes quite a while for that uranium to decay. And that's because uranium, remember, has a long half-life. So you saw that in the previous play posit. The decay of radioactive isotopes, how long it takes for it to decay, depends on their half-life. For carbon-14, the half-life is 5,730 years. And for uranium-238, the half-life is 4.5 billion years. So, of course, it's going to take quite a long time. Okay, we can still see here that this is going and going. So I'll pause it again, and then I'll show you the value when we get to 0. Okay, 40 billion years later, we are finally at 0%. It took 48,984,000,000 years for the uranium-238 in this rock to decay to 0%. All right, we've got one more thing to try. The last thing we're going to try is we are going to try to test carbon-14 in the rock. So let me go ahead and reset this. And I'm going to switch it to carbon-14. And once again, we're going to erupt that volcano so we can have our rock being born there. There it goes. Boom. And the probe is on carbon-14. So I want you to take a look at once the rock hits the probe, our Geiger counter probe, and cools off. What percent of carbon-14? Take a look at that. Right now, it's not cool yet, but it's at 0%. Let's see what happens when it cools. It's cool. Any change yet? Okay, so that leads you to question 8. Can we use carbon-14 to measure the age of the rock? All right, is carbon-14 the right isotope to measure the age of a rock, like this igneous rock here? All right, that is it for this simulation. You have some questions to answer in your video. Don't forget you have question number 9 as well. When you're done, don't forget to hit submit. Have a quality day.